You know when you pick up a product, maybe it's your mouse, your phone, even your car key, and you just kind of marvel at how perfectly smooth and sculpted it feels? Well, that's not magic, and it's way more than just art. It's actually a really precise science. So today, let's pull back the curtain and uncover the hidden secrets that turn a simple idea into a perfectly crafted product.
So how in the world do designers go from a totally blank screen to these incredibly complex, beautiful objects we use every day? The answer lies in a super powerful set of tools and techniques that, honestly, turn abstract ideas into physical reality. It's this amazing process that mixes raw creativity with some seriously clever engineering.
All right, so here's the first big secret. Professionals almost never, and I mean never, use their design software straight out of the box. Instead, they customize it. They turn a generic program into this high-performance cockpit that's tailored specifically for their workflow. Because for them, efficiency is absolutely everything.
Yeah, instead of digging through menus for the same sequence of commands over and over and over again, advanced designers literally build their own custom tools. They create these unique shortcuts and specialized commands to automate all the repetitive stuff, which saves them a ton of time and, more importantly, lets them focus on the actual creative work.
So, how does this actually work? Let's say a designer is always needing to zoom in on their model, but they want to ignore any virtual lights they've put in the scene. Normally, that's a whole process. You gotta select nothing, then select all the lights, then invert that selection, and then zoom. Instead of doing that every single time, they write a simple script. It's called a macro that just chains all those commands together. They stick it on a new button, and boom, a four-step process becomes one single click.
So a macro is basically just a saved recipe of commands. It transforms a tedious, multi-click chore into a single, powerful instruction. This is really the foundation of a professional workflow. You're building a personalized cockpit where every single control is exactly where you need it to be.
Okay, so having an efficient setup is key. We get that. But what about the design itself? Now we're getting to the real core secret of it all, a hidden mathematical principle that separates a model that looks, kind of amateur from a truly professional, high-quality product.
I want you to think about the reflection of light on a brand new car's door panel. See how it just flows perfectly? There are no weird breaks or kinks in it. What creates that seamless, almost liquid-smooth quality? How do designers possibly achieve that level of perfection in a digital model?
Well, the answer is a concept called continuity. See, it's not enough for two curves to just meet up. The real magic is in how they meet. Imagine you're blending two shades of paint. You don't want a hard line between them, right? You want a super smooth, gradual transition. That's exactly what designers are aiming for with their surfaces.
And this is where it gets really, really cool. There are different levels of this smoothness. First, you've got G1 continuity, which is also called tangency. This means the curves meet and they're pointing in the same direction. It looks okay, but if you shine a light on it, you'll see this subtle but really jarring break in the reflection. Then you have G2 continuity, or curvature. This is the gold standard. Here, the curves don't just meet and point the same way, they also curve away from that meeting point at the exact same rate. And the result? A flawless, seamless surface that looks perfect from every single angle. And this isn't just about looking pretty. On a car, this kind of perfection actually affects aerodynamics. On your phone, it communicates quality, and it just feels better in your hand.
But how can a designer even see this invisible mathematical quality? Well, they use a tool called a curvature graph. Think of it like this. The graph shows these little hairs that represent the amount of curve at every single point. If those hairs jump all of a sudden where two curves meet, that's a G1 connection. You're going to see a flaw. But if the hairs flow smoothly from one curve to the next, that's G2. That is the visual proof of perfection.
So, we have our perfect curves. But how do we actually build a 3D surface from them? This brings us to another huge idea. Designers don't think of their material as a solid block, but more like a kind of digital clay.
Okay, take a look at this sphere. On the left, it's a perfectly smooth object, right? But on the right, we see its hidden secret. Every single smooth surface, what designers call a NURBS surface, no matter how complex and crazy it looks, is actually defined by an underlying rectangular grid of control points. This is its fundamental structure.
This underlying grid is the key to how designers work. They don't directly touch the surface itself. Instead, they grab, they pull, and they push these control points on the grid, and the surface, our digital clay, stretches and deforms smoothly in response. It's truly digital sculpting.
Okay, let's put it all together.
How do these two massive ideas, these perfect G2 curves, and the digital clay of NURBS come together to create an actual product?
A project, like this trackball mouse, always starts with a framework. But it's not just any framework. Designers lay out this incredibly precise skeleton using those perfectly smooth G2 continuous curves we were just talking about. These high-quality curves define the most important shapes and make sure that the final surfaces are going to flow together absolutely seamlessly. So, the skeleton is built, the main surfaces are sculpted. Now it's time for the final phase, where this raw digital model gets polished into a photorealistic masterpiece.
You can think of this as the quality control stage. Designers use these specialized analysis tools to hunt for any tiny imperfection in the surface continuity. They make their final little tweaks to the control points, and then they get the model ready for rendering, which is the process of adding lighting, materials, and textures to create a totally lifelike image.
And here it is. This is the payoff. All that underlying work, the custom tools, the obsession with G2 continuity, the careful sculpting of that control point grid, it all leads to this, a final rendered product that looks completely real and perfectly manufactured, all born from these hidden layers of mathematical precision.
So, the next time you pick up a really high-quality product, take a closer look at its reflections. See if you can spot that flawless flow of light across its surfaces. Because now you know the secret. You're not just looking at plastic or metal. You're seeing the ghost of the perfect, hidden curves that give it form.